Hello, Assalamu alaikum. Good day. I welcome you back to this May 2020 semester, and I hope that you had a good break and your last semester was good. And I hope that you and your family are safe from this COVID-19 situation. We'll be having network analysis EEB 2023, and I'm expecting about 30 students this semester. My name is Syed Saad Azhar Ali, and something about me: I am from Pakistan, and those who have known me before, from maybe from circuit theory, I am from Pakistan. My specialization is in control systems and signal processing. I have been teaching circuit theory for some time. This is the first time I'm teaching network analysis, so I'm also excited. Also, I hope that you also excited. I know these times are not those easy times. These are difficult times, and we have to do this online learning. Yeah, I hope that we can work together for better learning and hopefully for better results as well. The main focus will be on how to effectively deliver the idea, the concept, and do a lot of practice. I will try to make it as close to classroom face-to-face teaching as possible. Not face-to-face, but actual solving the questions. So I hope that it will be a good experience for you, and I will keep you engaged within you guys as well. I'll like brief in a while, right? So let me go through the introduction of the course. All right, so EEB 2023 network analysis. This course is dealing about fundamental of network analysis, but this is one step ahead of the network analysis secretary. What's required for this course is basic knowledge from circuit theory and Laplace and Fourier transform from signal and systems. I believe these two are very important things to focus on, and if you guys remember things from circuit theory and signal and system, it will be like much easier to do this course. So I would like you guys to brush up your circuit theory and circuit and signal and systems. It will be like much easier uh, to do this course. Otherwise, you will face some problems. So this is like much more complex problems compared to circuit theory. Circuit theory had like DC normally, but we'll have AC and alternating sources and time dependent. So I'll brief you in a while. So basically same as circuit theory, but with advanced circuits. And the good thing is that it will be simplified in Laplace and Fourier domains. Some of you might be surprised that how is it simplified in Laplace and Fourier domains, because some people find it difficult to understand the Laplace and Fourier. So I'll try to go through some of the concepts that are required to understand the Laplace and Fourier's use in circuit theory, and you will see that it makes it much more simpler compared to time domain circuits. All right. So basically, the outcome of this course are to analyze. At the end of this course, you will be able to analyze second-order circuits in phasor domain, like the angle and the magnitude. You will be able to analyze circuits using Laplace transform. You will be able to analyze using frequency response in series and parallel circuits, and will be able to differentiate different types of filters. Similarly, as the Laplace transform, it will be about Fourier transform as well, and two-port networks. The good thing is you just have to. Where is my pointer? Can I enter? Oh, go back. Okay, it's okay. We'll have two tests, 40%, like 20 each. We'll have tutorials, assignments, and quizzes for 25%. This will have a heavy weightage. And of course, considering the online learning, we'll be having an extended assignment for 35%. I'll brief you in a while. We'll be taking Charles Alexander and Matthew Sadiku, book Fundamentals of Electric Circuit. We'll take fifth edition. There is sixth edition also available. I have the PDF version, and I think you can find it online as well. But I'll share the book with you. The prerequisite for this course are circuit theory and signal systems. So whatever we learned during circuit theory in terms of Kirchhoff laws, node mesh analysis, Thevenin's theorem, superposition theorem, all that will be required. And from signal systems, we need the Laplace transform and the Fourier transform. We will be reviewing some of those concepts here as well before we apply to real circuits, and we'll see why we learned Laplace and Fourier in signal systems so that we can apply it on different applications such as network analysis. It will be like much easier. So you have to have a grip on circuit laws and theorems and fundamentals of Laplace and Fourier transform. Teaching mode, the lectures of course will be online lectures using ulearn. There is a setup with which we can define the time for online video streaming, and the problem probably the student face is with a video lecture or with an online lecture, they don't have the liberty to experience actual classroom teaching. So don't worry, I will be using a whiteboard to demonstrate the circuit analysis. So it is like a real face-to-face class, along with, of course, PowerPoint slides. I'll demonstrate in a while. Then, of course, these lectures will be available for deferred viewing. So don't worry, if you want to recall something or you want to have a review or there is an internet issue at your end, you will be able to view these lectures later on. So let's take an example. All right, let's take this example as to show what I'm going to do in this semester for online learning. Normally, this is what you see on a PowerPoint slide, that you have to find V1 and V2 for this circuit. Normally, the lecturers present the solution, the typed solution, with the whole equation or the whole steps all together. The best that you see is using some animations, but I'll be doing it like a normal whiteboard. So I'm going to do it like this, that okay, this circuit has a current source of 10 sine 2t. It has one inductor, one capacitor, and one control source. So from the sine 2t we get that omega is equal to 2 radian per second. So we can convert the capacitor of zero point 0.2 into xc1 upon j 2.2 and xl for the inductor j2 times 2. This is basically 1 upon j omega c, and this is j then the omega and times the inductor. Then I'm going to say that okay, using nodal analysis we can write the node equations. So at node 1 we can write minus 10 sine 2t plus v1 upon 2 plus v1 minus v2 upon 1 upon j 2 times zero point 0.2 equal 0. So this is equation 1. Similarly, at node v2 we'll have v2 minus v1 upon 1 upon j2 times zero point 0.2 plus v2 upon j4 for inductor and v2 minus 3 vx upon 4, where vx is equal to v1, so this will be replaced by v1 as vx is equal to v1 equal 0. So this is just like a whiteboard. My writing is sort of okay, I hope that you can bear with that, but this way it's much easier rather than showing you the whole solution and then talking about it. I believe this will help you to learn in a better way, inshallah. Okay. All right. All right, so that was about the lectures. About the tutorials, we will have a split session in which in the first half or first quarter maybe I will demonstrate using the whiteboard, in which I will show how to solve a question. Later on, you will be divided into groups of 3. We are expecting about 30 students, so we'll have about 10 groups, and each group will be assigned 3 unique questions. So like for example, group 1 will have question number 1, 2 and 3. Group 2 will have 4, 5, 6 and so on. We will be using Microsoft Teams for these sessions. So in each session, the first quarter I'm going to explain uh, the topic and the concept. Later on, it will be like this. So let's say this is group 1. This one has 5 students, but you will have just 3. First question, first student in any order takes the lead. So you are in your own private meeting in Microsoft Team, and first student will start talking about the question. So he'll say, let's analyze this question. For example, so basically this is the group leader right now for this particular this question. So he's going to talk about it in a way that, let's analyze this question. This circuit has 3 nodes and 4 loops. You can see that, okay, these are the nodes, and he says that, okay, these are the loops. Okay, come on, hurry up. Okay, so he says let's choose nodal analysis as nodes are lesser than the loops. Okay, generally this is the way, but the group members can also pick if there's a mistake. Like this guy will say, hey, loops have current sources, so we don't need to count these loops. So this way it's like an interactive session. So uh, this remaining time in the tutorial, you guys in that private meeting, that the 3 of you will discuss the problem, and how do you submit is, you have to work in the online group call and meetings. Then each member in the team has to solve one of the 3 questions. So each member has to solve a question and record a video of the solution. So you can use paper and pen, or you can use typing, or I leave that to you, but you have to make a video of the solution. Okay, and then submit it in a way that you will save the question in a format that matches the question number. And these videos will be posted in a class repository accessible to all students. This way each of you will have an access to 30 solutions of 30 different problems. This will be huge in a way that you will have a lot of practice questions available with solutions. And of course, I'm sure that you guys are smart enough to find solutions somewhere, you know? Right? Yeah. Then how are we going to grade and do the assessments, the tutorial assignments? So of course, the collaborative team meetings, I will like pop in some of the meetings, and I'll see what are you guys discussing. So the time allocated for the group meetings, you have to discuss those questions. I can pop in anywhere I want because I will be the boss, you know. Then the submission will be the video solution. So the assignment part, the submission is a video solution for each of you. Those who do not submit will not get the marks. Uh, each lecture will follow up with an online quiz. The way I do it is like 1 week I'll take the quiz from the lecture, and 1 week I'll take the quiz from the tutorial. So 1 week is about the concept, the basic ideas, probably definitions, and the week following that will be solving a particular question, and we'll do it online uh, with a limited time assigned. Then we have 2 online tests, and of course the final extended assignment. You can contact me from your home, you know, We'll have scheduled sessions for consultations. So just like office hours, I will assign the scheduled times for consultations. You can like pop in or like just drop a message. You can contact me via email or following up using WhatsApp. I have created a WhatsApp group. The link is given here. I will probably make a QR code so that you can easily scan that. So this is it for the introduction. It's about 15 something minutes. But this is just introduction about the course, and hopefully that we'll have a good time in this semester. uh, I know these are difficult times, and it will be difficult for each one of you to learn using online modes, but I'll try to make it as easy as possible. Do not hesitate to ask questions. Do not hesitate to ask a question, whatever you think it is. It could be a foolish or stupid question, but no question is stupid. Trust me. Those who ask questions result in like better grades. So don't be hesitant in asking questions. All right. So see you for now, and we'll have our first lecture in the assigned time. Thank you. Bye. And I did not wish you all Salamat Hari Raya, Eid Mubarak.